let's start today by talking a little bit about your background. You've got quite an interesting career trajectory.
Yeah, so my background is in biomedical informatics, many years in different kinds of biomedical sciences, and always with an eye on sort of the application of it. And then have spent the last 4 years of my career at LinkedIn leading a data science team there. Yeah, I guess I get this question a lot, so I guess I would say that the logic behind it is that really informatics is a toolkit that can be widely applied to a variety of different domains. And so if I think about the things that I learned from the biomedical informatics kind of space, it's really about how do you use data to drive insights and to drive actionability. And so my work in personalized medicine really drove to what are the actions that we can take from understanding the data? How do we integrate disparate data sources together to create actionable plan? So in one case, it's where physicians can act on it, where different clinicians can act on it. And in the LinkedIn domain, it's where our product managers or executive team can act on it. So I can go on about this.
Well, go ahead. Is there another example? It's interesting.
Yeah, so let's see. So another example, I guess, would be communication. I would say, actually, that's another thing that's really critical. So, you know, when you do science, when you do a PhD, or when you work with different, in my case, it was different clinicians and different domain experts, you have to really explain beyond, you know, creating a new algorithm, a new methodology. You really have to have the explainability, right? Explain how is this methodology working and how can it be implemented. And that's to a variety of different stakeholders. And in the case of LinkedIn, my kind of stakeholders are executives, product managers, designers, engineers. And so it's this ability to translate what the data is telling us is really transferable across multiple domains. Yeah.
And so part of your work at LinkedIn is your team is working with teams from across the company, from product development to engineering teams to marketing teams. What kinds of challenges do you see in having the cross-functional teams working together?
Yeah. So yeah, definitely data science, I would say, is an inherently cross-functional role to play, and there's a lot of kind of translation and understanding that has to happen. So I would say, well, one challenge is hiring people. So I would say this is an area where there's such a variety of skills that are really essential to be able to do this role well, that finding people that can go across silos or across different organizations is important, right? So I guess the first thing to focus on is really how to hire well. And then when we work with different partners, I think a lot of it is really putting in place the partnership to have to be in sync on what are the goals that we're trying to achieve with the product or with the feature. And so working very well across really all of the different groups: product, engineering, design, business operations, marketing. And so we work as these teams that are very closely tied together so that for the data science perspective, you really can understand what are we trying to drive, what value are we trying to drive for our members, and then work together to use the data to derive insights that help with that. So if I think back to your question on challenges, it's really more about how do we have the teams working, you know, closely together in a way that they can iterate quickly, that they can align on timelines, and if there's a need to create a new methodology or a new analytical framework, how do we create the ability to have the tools in place and sort of the timelines aligned such that we can build foundations while still delivering on what the business and the product needs.
Is there any advice you could give other companies that are looking to incorporate a cross-functional team environment?
Yeah. So a number of different thoughts. Firstly, there are different models for how to use data science and how to create a data science team within an organization. One thing to think about is whether or not you do a centralized versus a decentralized model. In our case, with the maturity of the product that we have and with the type of speed that we want to have to iterate on our products and on our decision making using our data, the embedded model works really well. And so really having a person that is embedded within the team and becomes a domain expert and understands what the team is trying to drive for helps. So that's one thing. The second thing I'd say is really about, I'd say kind of divided into culture, process, and tools. Right? So to integrate data science and data usage in general into a company, I think what's critical is to have a culture of being data-driven. And so from my perspective, sort of every organization, every product And to some extent, every decision really should be either data-driven or data-informed. And so in terms of practically putting that in place, you have to actually create building blocks to enable that. And so a big part of that, for example, is democratization of data. Creating a way where anybody in the company, any stakeholder can ask a question of the data without having to go to the highly paid, highly trained, and scarce resource data scientists or data analysts. But being able to access tools where there's a shared understanding of the data that your organization has. And so, for example, one of the things that we've developed at LinkedIn is really develop a unified metrics pipeline so that everyone in the company is looking at the same measurement of the metrics that we care about and the same data sets. And then in addition to that, on top of that, sort of a UI that you can really interactively explore the data and engage with the data in a way that's self-served. And so that really lets you answer any question at your fingertips.
Right. And so getting back to the biomedical side of your work, you continue to advise biomedical companies. And so what kinds of interesting things are you seeing coming out of this space right now?
Yeah, there's a lot of interesting things. I'd say the areas that kind of interest me most, potentially because of my bias and background, is what's happening with clinical information that's being kind of opened up in a variety of ways. So there's a lot going on around healthcare policy and around kind of privacy and basically enabling data sets to be more easily exposed. And so while keeping privacy obviously intact, it enables a lot of things that previously weren't available to be ripe for innovation. And so you can get at sort of mashups of data in the healthcare space that I think is really critical and essential. And so we can take some of the learnings of large consumer web companies, for example, that are doing things sort of at massive scale, and now start to apply some of those platforms or those learnings into healthcare, where I think it's so critically needed. I said another area is, again, something that I've worked on in the past is we used to call it personalized medicine, now it's being called precision medicine. But this area where, just as, if you think about it, all web products that we use today, the great ones are really all about personalizing, right? So if we think about Amazon or Google or all of this, the companies that are really doing great recommendations, it's all about giving you kind of the right recommendation for you, the right information at the right time. Similarly, with medicine, right, we still have this one-size-fits-all model of delivering medicine in a generic way for patients versus getting really personal, whether it's using their genetics, using their environment, using their past family history, or their past history. And so starting to utilize that information, I think, is really key to unlocking better healthcare. And so what I'm excited about actually is a lot of my colleagues and a lot of people that have been in this space of data science, many of the people that have been working at the tech companies are now sort of transitioning into healthcare, realizing that this is really an area where there's a really important mission to go after. And so I think this is also an interesting area that's, in terms of the cost, for example, of doing genetic analysis that's going down. In terms of the openness of data, it's kind of a perfect storm of the right things happening to enable us, if not now, sometime in the very near future, to really open up a lot of exciting development, I think, in this space.
Right. And so, how far out do you think we are from experiencing personalized medicine in any kind of meaningful way? Like, when am I going to go to the doctor myself and have an experience like that? Yeah,
so it's hard to predict. I think 10 years ago we said 5 years ago, and do I say 5 years now or 10? It's a little hard. I think we're getting closer. My personal perspective is that really, massive changes in how we experience healthcare, I think we're still a ways out. So I think we're still at the kind of 10-year mark. Smaller changes on specific niches where we can really target. That I think is much closer, right? And we're already starting to see examples of that. And so I think it's getting closer.
Right. It's hard to make changes on such a global scale with something that's so large like healthcare. Yeah. Is that basically the major hang-up? Because the technology is really starting to come out, but the system, like if you look even at electronic records, and that's technically possible, and yet we can't get that. Is it just the size?
Well, it's a number of things. So I say one thing is actually data access, right? So even if you have different data sets, actually, if you can't get access to the data, if it's still a proprietary lockdown system, that's one challenge, right? Another challenge is, I would say, years ago we talked about how the goal is really getting the $1 million for doing a genetic assay, so doing sequencing down from $1 million to $1,000 to $100.
Right.
We're there now. What people have discovered is that it costs $1 million to actually do the analysis on it. Right? And so now the investment really needs to be in what do we do with all this data? How do we actually make use of it? And so I think smart ways of aggregating the information that we already know today in a very meaningful way and in a statistically rigorous way where we can actually drive to actionability, right? Where it's not just this is interesting, but this is the action that I can take is key. And I think a different very critical piece of that again is kind of in the works but is not yet there, is educating the doctors. Right? So many doctors still have never been trained in really understanding kind of informatics in this way of how do I actually take these findings and these recommendations from that we're seeing kind of in terms of, if I take, for example, pharmacogenomics, the field that I'm most familiar with, this is really about how do I understand single genetic differences and how that impacts your response to a drug and how that's different than my response, right? So I can tell you now what your genetics are, what my genetics are, but how do I actually translate that as a physician to, this is the drug that you should be taking versus this, or this is the exact dosage. We still actually need to train people to use that information.
How to make it actionable, right.
And so how to make it actionable and how to also then explain that to the patient. Beyond the doctor understanding it, how does the patient really understand that and how do they determine, among the choices that they have, how do I use this information to affect my lifestyle or to affect my, medication habits? And so I think those pieces are still critical. And so again, this is in the works. Many deans of medical schools have been discussing this. How do we integrate this, if not yet there? But that's also a big piece of it. So beyond getting the technology there and getting the analysis there, it's about the understanding of the analysis and the communication of the analysis back to the patient. That is a final link.
Right. Yeah. So I'd like to close our conversation today with sort of a broad personal question. Okay. What people or projects are you following? What are you finding personally fascinating these days?
Yeah. So I guess it would really be an extension of the last questions. I think that there's a very interesting trend right now of people that are really in search of what is, if I'm going to be doing this kind of work, what is the mission that I'm going to give my life to? And so I'm very interested personally in the application, right? So in our space, in the LinkedIn space, it's really connecting the world's professionals and realizing economic opportunity for the millions of people out there. Another important area, in my opinion, is healthcare, right? And then the third is education. And so I think all of these areas, personally to me, I'm very passionate about how do we use data and how do we really realize the potential of data and of data science to help further all of these three areas, because I think that it's so much at the basis of what we're trying to do. And so, if we're going to use our brain power, let's solve these really important problems that affect the whole world.
Right. Well, thank you very much for talking with me today. It was fun.
Thank you. Yeah, I had fun.